Hey everyone, I just wanted to post a little note today on intrinsic geometry and some ideas I've had floating around about it, which, as you can see displayed on the screen here, I've been consulting with my fallible AI assistant about. And just a quick note on using the AI. It's not like that. Don't take this as a sign that I'm in favor of the tech singularity, or what Chris contrasts with the human singularity in his paper Meta Religion as the human singularity. I'm fully aware that the powers that be would like to use this and other technologies to advance their interests, which are basically to parasitize us. I just think that while we have these tools available to us, we might as well go ahead and use them to their fullest possible advantage towards toward the advancement of human knowledge and the human singularity. So that's my intention with this. Alright, so intrinsic geometry. Yeah, the thought that I had was that basically the idea with intrinsic geometry can be captured by viewing yourself as an observer limited to the domain to which the geometry is intrinsic to. In other words, in the example of the intrinsic geometry of the surface of the sphere, I said yesterday that it's like you're a two-dimensional being living on the surface of the sphere, and looking around you, you can only see as your entire perceptual universe the surface of that sphere. And so what in Euclidean geometry would be considered straight lines are in this sphere surface world that you find yourself are now these great circles or geodesics, which are parts of the great circles, where a great circle is the largest possible circle that you can make around the sphere. And there are an infinite number of those, and they all intersect at 2 points, and they basically correspond to like the lines of longitude on the Earth. Those are the great circles. So these would appear to you to be straight lines from an internal perspective, but they don't behave the same way straight lines do in Euclidean space, because they intersect each other at the 2 poles of the sphere, for example. And in a similar way, any intrinsic geometry is like taking the vantage point of an observer that is within that domain that the geometry is said to be intrinsic to. And I consulted with the AI a little bit about that, and it basically backed up and said that I was fully in the right in thinking about it that way. I kind of had this interesting discussion about the fact that, well, isn't mathematics, geometry, any field of mathematics in general, intrinsic in a sense, because it's limited to the perspective of just taking the axioms and rules of inference that are at play, or whatever base syntax is at play, and just operating within it. And it said that that I brought up a nuanced point about the foundational role of axioms and the self-contained nature of any mathematical system, whether it be geometry, topology, or another area of mathematics. Indeed, any mathematical system defined by a set of axioms and inference rules is self-contained in the sense that all statements, proofs, and derived properties within that system are based solely on these axioms and rules. This implies that every geometry is, in a sense, intrinsic to its axioms, and that in any mathematical framework, it's closed in the sense that you can't derive things that are outside of those axioms. I guess you could say that limitative results like Gödel's incompleteness theorems do provide true statements within the system that can't be derived from the axioms, and that's an interesting limiting case to explore further. But I think the basic point was valid, at least outside of those limiting cases. Here I got into something that was accidentally a little bit above my pay grade. I'm just going to gloss over that. So I asked it, so in every instance of intrinsic geometry, you can view it as taking the perspective of an observer, only able to observe from an internal vantage, the specified domain to which the geometry is intrinsic. I said, yes, that's an excellent way to conceptualize intrinsic geometry. Thank you. It's always satisfying to get affirmation like that from the robot. And so basically, I asked it, another thought that I had can any specifiable domain be the basis for an intrinsic geometry if you just take the perspective of being interior to that domain and just looking around within it, not able to see anything outside of it, and just reasoning from there? And he said, in theory, the concept of intrinsic geometry can indeed be applied to virtually any specifiable domain by limiting your observational perspective to one that is strictly internal to that domain. This approach to understanding geometry from an intrinsic perspective is very powerful and adaptable. Excellent to hear. You can do that with continuous domains. I was thinking obviously the sphere case and other cases like hyperbolic geometry, and then discrete instances like just a set with elements or a graph, or here gives the example of digital geometry. Interesting examples, and even more abstract mathematical constructs. So there you go, basically a really intuitive way that I've been thinking about to think about the nature of intrinsic geometry is just envisioning yourself as an observer within that specified domain that the geometry is said to be intrinsic to. And just imagining that you can't perceive anything outside that domain. How might a mathematician, with those observational constraints, formulate a geometry about what they see? Very cool. All right.